See here, what it is displaying, the maximum amplitude is 10. So whether it is right or not, how we can come to know? Because I only pass the value for signal. What is the value I multiplied here with 10? So I multiplied with 10. So obviously the maximum value is going to be at pi by 2 will be getting. Sign for the sign will be getting maximum value as 1. But since it is getting multiplied with 10, that 10 it is displaying. For suppose if I write here minimum value, MIN. I just want to run it. Yeah, minimum is minus 10. So it is showing minus 10. Here I didn't edit the name, that's why it is showing max. Okay. So for our understanding, if you want to add both max and minimum field, you can add. Or if you want to find out the standard deviation, that can be added. Any other feature that you want to display here, you can add, keep on add upon the components, and then according to your wish, you can design the panel. So this is how you can design your signal processing toolbox. Understand from this experiment, as I said, what are all the concepts you can learn, how the signal can be loaded and then viewed, original signal. If at all any noise is added for your signal, using the basic concepts what you have learned earlier from the DSP, apply any filtering according to the requirement, either it is a low pass, high pass, or band pass, based on the frequencies that you want or based on the frequencies you are eliminated. You can design your own filter, and then you want to extract some parameters from the signal, noise removed signal. So from the noise removed signal, you can apply some mathematical formulas. For suppose I have told here finding the maximum amplitude and minimum amplitude. So according to your own requirement, so whatever feature, either it may be entropy or standard deviation or variance, maximum peak, minimum peak, all these features you can estimate, and based on that you can come to a conclusion. And if it is a biosignal, you can use it for diagnosis purpose. So, for example, the example earlier what we took is a heart signal. If it is a heart signal, you can find out the heart rate. From the heart rate, you can find out the parameter, whether it is, you can find out the time period. Time period heart rate can be estimated. That is abnormal or normal. Tachycardia or bradycardia can be classified. So this is how you can do. You can play with signal processing applications. Now I want to touch even one example from your image processing. So we'll see another example from image processing now. Just going to erase this. So I'm just gonna close this app.